December 8th, 1941. Clark Field, Philippines. Colonel Takeshi Nakamura stood in the pre-dawn darkness watching the last American B-17 bomber burn on the runway. His engineering battalion had secured the airbase in less than 3 hours, and now came the critical work that would determine how well Japanese forces understood their new enemy. Nakamura had spent 15 years evaluating military equipment for the Imperial Japanese Army, analyzing everything from Chinese rifles to captured Soviet tanks. His reports shaped procurement decisions that affected hundreds of thousands of soldiers across the Pacific Theater. But the intelligence directive he'd received from Tokyo 3 days earlier carried unusual weight. The Americans were deploying a new light vehicle in unprecedented numbers. Every captured example was to be examined immediately, measured precisely, and analyzed thoroughly. Understanding American manufacturing capabilities had become as important as understanding American military doctrine. Private Hasegawa called out from behind a damaged hangar, his voice carrying the excitement of discovery. Nakamura made his way through scattered debris, expecting to find another abandoned truck or staff car. Instead, his engineering team had gathered around what appeared to be the smallest military vehicle he'd encountered in his entire career. The Willys MB sat in the pale morning light like a mechanical contradiction. Its compact dimensions measured just 80 inches from bumper to bumper, barely larger than a civilian motorcycle with a sidecar. The olive drab paint showed minimal wear, suggesting recent delivery from American factories. Most striking was the vehicle's obviously lightweight construction. Thin metal panels, bent at simple right angles, a basic canvas top, and minimalist approach to everything from fenders to dashboard instruments. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Lieutenant Kobayashi, Nakamura's senior technical analyst, walked slowly around the Jeep with the practiced eye of someone who had dismantled hundreds of vehicles. "Sir, this appears to be their standard reconnaissance vehicle. We found similar examples abandoned at 3 other positions across the airfield." His voice carried a tone that fell somewhere between skepticism and curiosity. Japanese military doctrine emphasized robust construction and substantial engineering, principles that seemed completely absent from this American creation. Nakamura climbed into the driver's seat, immediately noting how cramped the space felt compared to Japanese military trucks. His frame, average by Japanese standards, filled the compartment completely. An American soldier of typical build would find the quarters even more restrictive. The dashboard displayed just 5 gauges: fuel, oil pressure, water temperature, ammeter, and speedometer. No complex instruments, no sophisticated controls, nothing that couldn't be understood by someone with minimal mechanical training. The simplicity initially suggested inferior engineering, the kind of manufacturing shortcuts that prioritized production speed over battlefield effectiveness. But as Nakamura examined details more closely, he began noticing elements that challenged his preliminary assessment. The steering column could be adjusted for different driving positions. The gear shift pattern included both 2-wheel and 4-wheel drive options, selectable while moving. Most intriguingly, every component appeared designed for rapid replacement rather than long-term durability. "Let's examine the engine," Nakamura called to Kobayashi, who was already approaching with precision measuring instruments. Military vehicle power plants were Kobayashi's specialty. He'd analyzed captured Soviet engines after the Nomonhan incident, German designs obtained through technical exchange agreements, and every Japanese military engine produced since 1935. His mechanical intuition had helped improve Japanese vehicle designs across multiple categories. Kobayashi released the hood latches and lifted the engine cover, revealing a power plant that defied conventional military engineering principles. The Go Devil inline 4-cylinder engine displaced 2,199 cubic centimeters and produced 60 horsepower, according to the identification plate. But what struck Nakamura most forcefully wasn't the engine's specifications, Rather, it's obvious optimization for mass production rather than individual excellence. This is a civilian automotive engine, Kobayashi observed, his practiced hands tracing cooling system components, water-cooled, side valve design, nothing sophisticated about the engineering. It's essentially the same technology American companies have been using in passenger cars since the 1920s. His voice carried the disappointment of someone expecting to discover advanced technology, only to find pedestrian solutions disguised as military equipment. But Sergeant Yamada, who had maintained Japanese vehicles under combat conditions in China for 3 years, offered a different perspective. Sir, look at the maintenance accessibility. Every component can be reached without removing other parts. The oil filter sits right here, easily accessible. The spark plugs are positioned where any mechanic could replace them in minutes. The carburetor can be serviced without specialized tools. Yamada's endorsement carried weight because he'd earned a reputation for brutal honesty about equipment performance under field conditions. Nakamura found himself facing an analytical puzzle that challenged fundamental assumptions about military vehicle design. Japanese engineering emphasized sophistication, precision manufacturing, and components built to survive decades of service. The WWII's MB embodied completely opposite principles: simple technology, accessible maintenance, and design choices that suggested the vehicle was meant to be replaced rather than indefinitely maintained. The captured maintenance manual discovered in the glove compartment told a story that seemed impossible by Japanese engineering standards. The vehicle had been delivered to Clark Field just 8 weeks earlier, part of a shipment that included 300 similar machines. The manual's production date showed July 1941, suggesting American factories were manufacturing these vehicles at unprecedented rates. Nakamura straightened up and looked at his team gathered around the small American vehicle. Gentlemen, I need complete analysis within 48 hours. Measure everything, weigh every component, document every design decision. Tokyo wants to understand not just what the Americans built, but how quickly they can build it. He paused, studying the Jeep's simple construction. I suspect we're about to learn something that will change how we think about this war. The systematic disassembly began at dawn the following morning in a requisitioned hangar at Clark Field. Nakamura had assembled his most experienced engineers and obtained precision measuring instruments from the captured American workshops. What started as routine technical evaluation transformed into something approaching archaeological investigation. Every component would be measured, weighed, analyzed, and understood before reports went to Imperial General Headquarters. Kobayashi began with the chassis, using calipers to measure frame thickness at dozens of points along the vehicle's length. The results challenged fundamental assumptions about military vehicle construction, where Japanese trucks employed heavy-gauge steel ranging from 4 to 6 millimeters thick. The American frame measured consistently at just 2 3/4 millimeters. Yet, somehow, this thinner material had been formed and welded into structures that appeared adequately rigid for military service. The construction philosophy is completely different from our approach, Kobayashi reported as he examined frame joints and reinforcement points. Instead of using material thickness for strength, they've achieved structural integrity through geometric design. Look at these box section configurations. They provide rigidity through shape rather than mass. The American engineers had created reinforcement through strategic bends and cross-bracing, using the material's form rather than its weight to provide stiffness. The body panels revealed even more dramatic material savings. Japanese military vehicles used steel panels ranging from 2 to 3 millimeters thick, providing durability through raw material strength. The Jeep's body panels measured just 1 millimeter throughout, less than half the thickness Japanese engineers would specify for equivalent applications. Nakamura calculated the implications with growing concern. The Americans were building military vehicles using roughly 40% of the steel Japanese designs required. Sergeant Tanaka, who specialized in automotive electrical systems, delivered his analysis of the Jeep's wiring harness with barely concealed amazement. Sir, this entire electrical system uses standardized 6-volt components identical to civilian automotive specifications. No military-specific designs, no specialized manufacturers required. Any factory producing civilian car parts could manufacture these components. He gestured toward the simple voltage regulator and starter motor. Our military vehicles require custom electrical components built to unique specifications. This American machine uses parts that probably cost a fraction of our equivalent systems. The four-wheel drive system presented the most revealing insights into American manufacturing philosophy. Japanese engineers viewed four-wheel drive as a specialized capability requiring complex, heavy components suitable only for specific applications. Nakamura's team had spent years developing four-wheel drive systems for Japanese military trucks, creating sophisticated mechanisms that reflected careful engineering and precision manufacturing. The Jeep's transfer case weighed just 31 kilograms compared to over 70 kilograms for equivalent Japanese components, yet provided more operational flexibility. Two-speed operation with part-time engagement, reported Chief Mechanic Suzuki, who had spent the morning tracing every gear tooth and bearing surface. High range allows road speeds up to 100 kilometers per hour. Low range provides maximum torque for extreme conditions. The operator can engage four-wheel drive while moving without stopping or complex procedures. Japanese four-wheel drive systems required vehicles to halt completely for engagement, a process taking several minutes and considerable mechanical knowledge. The American solution achieved superior functionality with half the weight and twice the operational simplicity. Nakamura realized he wasn't looking at inferior engineering, but at a completely different set of design priorities. The intelligence reports arriving from Tokyo added industrial context that transformed technical curiosity into strategic concern. Captain Ishida had compiled American production data gathered from captured documents, intercepted communications, and intelligence sources in neutral countries. The numbers he presented challenged everything Japanese planners understood about automotive manufacturing capabilities. The Willys MB entered production in July. It's 1941, Ishida reported, spreading documents across Nakamura's makeshift desk. Initial production rates were approximately 50 vehicles per day at the Willys Overland factory in Toledo, Ohio. But American planners weren't satisfied with those numbers. They brought Ford Motor Company into the program to manufacture identical vehicles under the designation GPW. Nakamura studied the production figures with growing unease. 50 vehicles per day represented more than Japanese manufacturers produced in an entire month across all military vehicle categories, and the Americans were just beginning. By November 1941, combined Willys and Ford production reached 200 vehicles daily. That's 1,400 Jeeps per week, 6,000 per month. The Americans have already delivered over 15,000 of these machines to their military forces. The implications extended far beyond simple transportation. Each Jeep represented tactical mobility, communication capability, supply distribution, and battlefield flexibility. Multiply those capabilities by thousands, then tens of thousands, and the strategic advantage became overwhelming. Japanese forces advancing across the Pacific were encountering American units that could maneuver with unprecedented freedom, sustain operations with remarkable efficiency, and adapt to changing battlefield conditions with extraordinary speed. Lieutenant Kobayashi delivered his complete parts analysis on the afternoon of December 10th, 2 days after the initial capture. His methodical documentation revealed the deepest level of American manufacturing innovation. I have catalogued every component in this vehicle and compared the results against our standard Type 95 truck, he reported. The American machine contains 63% fewer individual parts than our equivalent vehicle. Nakamura studied the comparison charts with profound unease. Where Japanese trucks required complex assemblies with multiple subcomponents, the Americans had designed single pieces that performed multiple functions. The body construction exemplified this philosophy perfectly. Japanese vehicle bodies required skilled craftsmen to form complex curved panels using traditional metalwork techniques that had changed little since the 1920s. Each panel was individually shaped, welded and finished, processes requiring considerable time and specialized labor. The Jeep's body consisted entirely of flat panels bent at right angles with no complex curves or specialized forming requirements. Any reasonably equipped factory could stamp out these panels at high speed using relatively simple tooling, Kobayashi explained. The geometric simplicity that initially appeared crude now reveals itself as a sophisticated manufacturing strategy designed for maximum production efficiency. The electrical system demonstrated the same ruthless elimination of complexity. Japanese military vehicles used separate switches, relays, and junction boxes for different electrical functions, requiring extensive wiring harnesses and multiple connection points where failures could occur. The Jeep's electrical system integrated multiple functions into single components, using standardized connections that could be serviced by any mechanic with basic training. They have eliminated complexity without sacrificing capability, Nakamura concluded as he reviewed the accumulated data. Every design decision prioritizes manufacturing efficiency and field maintenance over engineering sophistication. This represents a complete philosophical reversal from our practice, where engineering excellence is demonstrated through mechanical complexity and precision manufacturing. The captured production schedules, discovered in the airbase administrative offices, revealed information that transformed Nakamura's technical analysis into strategic warning. American military planners projected Jeep production reaching 400 vehicles per day by mid-1942, then scaling to 600 daily by year's end. These weren't aspirational targets. They were conservative estimates based on industrial capacity already under construction. Nakamura spent the evening of December 10th calculating implications that would shape his report to Tokyo. If American projections proved accurate, they would produce over 180,000 Jeeps during 1942 alone. That represented more military vehicles than Japan had manufactured across all categories in the past decade, and the Americans were simultaneously ramping production of tanks, aircraft, artillery, and every other category of military equipment. The strategic assessment taking shape in Nakamura's analysis painted a picture of industrial warfare at scales Japanese planners had never seriously considered. American equipment wasn't necessarily more sophisticated than Japanese designs. It was optimized for completely different priorities. Where Japanese engineers maximized individual performance, American designers maximized production efficiency. Where Japanese manufacturing emphasized craftsmanship, American factories emphasized standardization and interchangeability. As Nakamura drafted his preliminary report, he recognized that his team had discovered something far more significant than a well-designed vehicle. They had encountered an entirely different approach to modern warfare, one that treated industrial capacity as the ultimate strategic weapon. The question wasn't whether Japanese engineers could design equivalent vehicles. The question was whether Japanese industry could manufacture them in quantities that mattered. The testing began at dawn on December 11th, with Nakamura's team preparing captured American equipment for systematic performance evaluation. Clark Field's perimeter offered terrain that ranged from paved runways to rough jungle paths, providing opportunities to assess the Jeep's capabilities across conditions similar to those Japanese forces would encounter throughout the Pacific Theater. Sergeant Yamada positioned himself behind the wheel for the initial trials, while Nakamura occupied the passenger seat with his clipboard and stopwatch. The skepticism his team had expressed during initial examination had evolved into professional curiosity about how American engineering choices translated into actual performance. Yamada turned the ignition key, and the Go Devil engine caught on immediately, settling into a steady idle that sounded surprisingly refined for military equipment. The first surprise came when Yamada engaged the clutch and shifted into first gear. Instead of the heavy mechanical resistance typical of Japanese military trucks, the transmission moved with smooth precision that felt closer to civilian passenger cars than combat vehicles. Yamada pressed the accelerator cautiously expecting modest acceleration from the vehicle's relatively lightweight construction. The Jeep surged forward with immediate responsiveness that caught both men off guard. Where Japanese military trucks required careful throttle management and patient gear changes, this American machine responded to the slightest input with eager acceleration. Within 50 meters, they were traveling at speeds that would have required twice the distance in standard Japanese military vehicles. The power-to-weight ratio is significantly better than our trucks, Nakamura observed, recording performance data. Their 60-horsepower engine moves only 1,300 kilograms compared to our trucks pushing 2,000 kilograms with similar power output. The Americans have optimized for efficiency rather than payload capacity. The real revelation came when Yamada steered toward rougher terrain beyond the airfield's maintained areas. Recent tropical rains had created muddy conditions and standing water that routinely challenged Japanese vehicles. The Jeep's narrow tires and lightweight construction appeared completely inadequate for serious off-road work, confirming expectations about American engineering priorities. But when Yamada engaged the four-wheel drive system with a simple lever movement, the vehicle's character transformed completely. Power distributed to all four wheels with mechanical precision that maintained traction across surfaces that would have challenged conventional vehicles. The Jeep navigated through mud, climbed over obstacles, and maintained forward progress across terrain that had stopped Japanese trucks during previous operations. Most dramatically, when Yamada deliberately drove into a position where the vehicle became partially stuck between rocks, Nakamura discovered he and the sergeant could simply lift the rear end and reposition it manually. The Jeep's 1,300-kilogram weight meant two men could accomplish what typically required mechanical winches or additional vehicles. This capability transformed every potential stuck situation from a major operational delay into a minor inconvenience. As they completed the performance testing and returned to the hangar, Nakamura found himself recalculating assumptions about military vehicle design. The Americans hadn't built a sophisticated machine. They had built a practical tool optimized for rapid production and effective operation under field conditions. Every engineering decision served those priorities, even when it meant sacrificing traditional measures of quality or complexity. The intelligence update that arrived on December 12th transformed Nakamura's technical analysis into strategic alarm. Captain Ishida had received new information from Tokyo intelligence services, data gathered from American newspapers, trade publications, and intercepted military communications. The production numbers exceeded even the most pessimistic Japanese estimates. American automobile manufacturers are converting civilian production lines to military specifications, Ishida reported, his voice carrying an edge of concern that Nakamura had never heard before. General Motors, Ford, Chrysler, and dozens of smaller companies are retooling factories that formerly produced civilian cars. The Americans built 4 million civilian automobiles in 1940 alone. They're now redirecting that industrial capacity toward military equipment. Nakamura felt a cold understanding settle over him as he absorbed the implications. The Japanese automotive industry produced approximately 30,000 civilian vehicles annually across all manufacturers. The Americans were operating at industrial scales more than 100 times larger, and they were converting that massive capacity toward military production with bureaucratic efficiency that Japanese planners had assumed impossible for democratic societies. Current projections suggest the Americans will produce 640,000 Jeeps by the end of 1945, Ishida continued, referencing classified estimates compiled by Japanese military intelligence. That's more than 100,000 vehicles per year, sustained for 4 years. It represents a level of industrial mobilization unprecedented in modern warfare. The numbers seemed impossible by Japanese reference frames. 640,000 vehicles of a single design, more military transportation than Japan had fielded in total across all vehicle categories since the Meiji Restoration, and the Jeeps represented just one category of American military production. Tanks, aircraft, artillery, ships, all were being manufactured at similar scales that defied Japanese industrial capacity. Nakamura's final report to Imperial General Headquarters, completed on December 14th, marked the conclusion of the most comprehensive foreign equipment analysis ever conducted by Japanese military engineers under combat conditions. But his conclusions challenged conventional wisdom in ways that made him profoundly uncomfortable about their implications for Japan's strategic position. The technical assessment documented genuine American engineering achievements. The Jeep represented sophisticated solutions to complex manufacturing problems, eliminating unnecessary complexity while maintaining operational effectiveness. Its designers had created a vehicle that could be produced quickly, maintained easily, and operated effectively by soldiers with minimal training. Every engineering decision served practical military requirements rather than abstract measures of technical excellence. But the production capacity behind those engineering achievements represented something far more threatening than individual vehicle performance. The Americans had built an industrial ecosystem capable of sustained military production at scales Japanese planners had never seriously considered possible. Where Japanese industry struggled to meet monthly production targets of hundreds of vehicles, American factories were preparing to manufacture thousands daily. The implications extended beyond manufacturing capability to fundamental questions about strategic planning and resource allocation. Nakamura realized that American military doctrine didn't just assume logistic superiority, it was built entirely around industrial capacity that could sustain massive equipment losses and still maintain operational tempo. Japanese doctrine assumed careful preservation of limited resources because replacement was difficult or impossible. The Americans were designing warfare around abundance. This vehicle isn't just transportation, Nakamura wrote in his concluding analysis. It represents American strategic philosophy made mechanical. They have built equipment that prioritizes quantity over individual excellence, replaceability over durability, and operational simplicity over engineering sophistication. These choices make perfect sense when industrial capacity allows producing replacements faster than combat can destroy them. The final paragraph of his report contained a warning that would prove prophetic as the Pacific War progressed. Japanese forces possess technical skill and tactical excellence that currently exceeds American capabilities in many categories. But we are entering a war where industrial capacity may prove more decisive than individual equipment quality. The Americans can afford to lose vehicles, aircraft, and ships because their factories produce replacements faster than we can destroy them. This represents a type of warfare for which Japanese military planning has not adequately prepared. As Nakamura's report made its way through military channels toward Tokyo, events were already validating his concerns in ways that exceeded even his pessimistic projections. American Jeep production continued accelerating throughout 1942, reaching and then surpassing every target military planners had established. The industrial mobilization Nakamura had documented at Clark Field was just beginning. The reality of American industrial mobilization became increasingly apparent as 1942 progressed and intelligence reports documented production numbers that Japanese planners initially dismissed as impossible exaggeration. But verification from multiple independent sources confirmed the staggering scale of American automotive production redirected toward military purposes. By June 1942, Willys Overland's Toledo factory was completing 350 Jeeps daily, operating 3 shifts with a workforce that had expanded from 4,000 to over 15,000 employees in less than 8 months. Ford's facilities were adding another 300 vehicles per day using production techniques developed for civilian automotive manufacturing and adapted for military specifications. The combined output exceeded 2,500 Jeeps weekly, more vehicles than Japan's entire automotive industry produced monthly across all categories. Lieutenant Colonel Fujimoto, assigned to analyze American industrial capacity for Imperial General Staff, compiled reports that painted an increasingly alarming picture of the strategic imbalance. American automobile companies employed over 500,000 workers in 1941. His assessment noted, those workers manufactured 4.7 million civilian vehicles using production lines, tooling, and expertise that now serves military requirements. Japan's automotive sector employs approximately 40,000 workers, producing 30,000 vehicles annually. The Americans operate at industrial scales more than 100 times our capacity. The steel production numbers revealed even deeper structural disparities. American steel mills produced 75 million tons in 1941, while Japanese production totaled 7 million tons. This 10-to-1 advantage in raw material production translated directly into military equipment manufacturing capacity. Every category of military hardware, from vehicles to ships to aircraft, ultimately depended on steel availability, and the Americans possessed overwhelming superiority in the fundamental industrial inputs that determined production capacity. But the most disturbing intelligence came from captured American planning documents discovered during the invasion of the Philippines. These materials revealed that American military planners had projected wartime production targets years before Pearl Harbor, systematically preparing industrial mobilization plans that assumed large-scale conflict requiring unprecedented manufacturing output. A captured memorandum from the United States Army Quartermaster Corps, dated August 1941, specified requirements for tactical vehicles the Japanese analysts found difficult to comprehend. Estimated requirement: 500,000 light reconnaissance vehicles for deployment across all theaters by December 1945. Production to be distributed among multiple manufacturers to ensure supply continuity even if individual facilities are damaged by enemy action. The document revealed strategic thinking that operated at scales Japanese military planning had never seriously considered. The Americans weren't just preparing to fight a war, they were preparing to overwhelm opponents through sheer volume of material production, and they had started that preparation while officially maintaining peacetime neutrality, converting industrial capacity toward military purposes months before actual combat began. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Captain Watanabe, who had studied American industrial practices before the war while serving as military attaché in Washington, provided context that explained the seemingly impossible production numbers. American automotive manufacturing operates on principles fundamentally different from Japanese practice, he explained in a briefing to senior staff officers in March 1942. Their factories don't build vehicles. They assemble standardized components manufactured by hundreds of specialized suppliers. The distinction proved crucial for understanding American production capacity. Japanese vehicle manufacturing concentrated in a few major companies that produced most components internally. This vertical integration ensured quality control but limited production flexibility and maximum output. American manufacturers orchestrated vast networks of subcontractors, each producing specific components to standardized specifications that allowed assembly at multiple final production facilities. Willys Overland doesn't manufacture Jeep engines, Watanabe continued. Those come from multiple suppliers, including Continental Motors, Willys itself, and Ford. Transmissions come from Warner, axles from Spicer, electrical components from dozens of different manufacturers. The final assembly plant simply puts together components produced across the entire American industrial base. This distributed production model allowed Americans to scale output in ways impossible for vertically integrated manufacturers. If one supplier reached maximum capacity, additional suppliers could be brought online. If bombing damaged one assembly plant, production shifted to other facilities using identical components. The system possessed redundancy and flexibility that Japanese concentrated manufacturing could never match. The full implications emerged as American Jeep production continued accelerating throughout 1943 and into 1944. Monthly production that had seemed impossible in early 1942 became routine baseline output. The Americans weren't just meeting their initial production targets, they were consistently exceeding them while simultaneously ramping up manufacturing across every other category of military equipment. By January 1943, combined Jeep production exceeded 10,000 vehicles monthly. By June, that number reached 15,000. The Americans were manufacturing more military vehicles every 2 days than Japanese industry produced in an entire month, and these weren't crude, hastily assembled machines sacrificing quality for quantity. Field reports from Japanese forces encountering American equipment confirmed that the vehicles performed reliably under combat conditions, maintained operational capability despite harsh treatment, and could be serviced using standardized procedures that required minimal specialized training. Major Ishikawa's intelligence assessment from Guadalcanal in August 1943 provided ground truth validation of American logistical superiority enabled by Jeep production. American forces operate with tactical mobility impossible for Japanese units, his report stated bluntly. Every infantry company possesses multiple vehicles for command, communication, supply, and medical evacuation. They maneuver across terrain we consider impassable, sustain operations we would judge logistically impossible, and adapt to changing battlefield conditions with speed we cannot match. The tactical advantages multiplied across every level of military organization. American battalion commanders coordinated operations from mobile command posts that moved with advancing infantry. Supply officers distributed ammunition, food, and medical supplies using vehicle fleets that operated continuously. Artillery observers directed fire from positions that could be relocated within minutes when Japanese forces attempted counterfire. Medical personnel evacuated wounded soldiers to aid stations within hours rather than days. Most significantly, Ishikawa's report concluded, the Americans treat vehicle losses as routine operational expenses rather than catastrophic equipment failures. We observed them abandon damaged jeeps that would require more than basic field repairs, simply destroying the vehicle and requisitioning a replacement. This indicates supply confidence we cannot comprehend, much less match. The production numbers that validated Ishikawa's observations continued growing as 1944 progressed. American factories maintained relentless output that accumulated into overwhelming material superiority. By June 1944, as Allied forces landed in Normandy and American island-hopping campaigns accelerated across the Pacific, total Jeep production exceeded 400,000 vehicles. By December, that number reached 500,000. Japanese intelligence analysts tracking these figures recognized they were witnessing industrial mobilization unprecedented in modern warfare. The Americans had manufactured more vehicles of a single military design in 3 years than most nations, produced across all categories in decades. And Jeep production represented just one element of American military manufacturing that included tanks, aircraft, artillery, ships, and every other category of military equipment simultaneously scaling to similar overwhelming levels. The human cost of this industrial disparity became tragically apparent as Japanese forces found themselves consistently outmaneuvered, outsupplied, and overwhelmed by American units operating with material advantages that Japanese commanders could never match. Lieutenant Yamamoto, no relation to the engineer who had first analyzed captured jeeps in the Philippines, commanded an infantry company during the defense of Saipan in June 1944. His after-action report, written in a prisoner of war camp, provided a soldier's perspective on fighting an enemy with unlimited industrial support. Our company possessed 2 trucks for all supply and transportation requirements, Yamamoto wrote. Both vehicles were over 3 years old, maintained through improvised field repairs using scavenged parts. When one truck became immobilized by mechanical failure, our operational capability decreased by 50%. We treated those trucks as irreplaceable assets because they were effectively irreplaceable. He contrasted Japanese logistics with what he observed of American operations. The enemy infantry battalion advancing against our positions possessed over 60 vehicles for various purposes. We destroyed 7 during the first day of combat. The next morning, they had been replaced. We immobilized another 4 the following day. Those were also replaced within 24 hours. It became clear that American logistics operated on principles completely different from our experience. They possessed equipment in such abundance that losses which would cripple Japanese units barely affected their operations. The industrial capacity enabling such abundance became even more apparent as 1945 progressed and American forces closed in on the Japanese home islands. Intelligence assessments compiled by surviving Japanese military analysts documented production figures that seemed to mock Japan's industrial limitations. By March 1945, American Jeep production totaled 600,000 vehicles. By June, that number exceeded 620,000. The final production tally, compiled after the war, ended in August 1945, documented 639,537 Jeeps manufactured in just 4 years. Colonel Nakamura, who had initiated the comprehensive analysis of captured Jeeps at Clark Field in December 1941, found himself stationed in Tokyo during the war's final months. His duties included evaluating intelligence reports and providing technical assessments to military leadership struggling to comprehend the scale of Japan's strategic defeat. When the final American production numbers reached his desk in September 1945, he spent a long evening calculating implications that had become painfully obvious years earlier. 639,000 vehicles of a single design. Production averaged over 160,000 vehicles annually, sustained for 4 consecutive years. That represented more than 5 times the total number of military vehicles Japan had manufactured across all categories during the entire war. The Americans had built more Jeeps in a single year than Japan's automotive industry had produced in its entire history. But Nakamura recognized that the production numbers themselves told only part of the story. The Jeep program demonstrated American industrial philosophy made manifest, treating manufacturing capacity as the ultimate strategic weapon. Where Japanese engineering emphasized creating superior individual equipment, American industry emphasized creating adequate equipment in overwhelming quantities. Where Japanese planning assumed careful preservation of limited resources, American logistics assumed unlimited replacement capability. The technical analysis Nakamura had conducted in 1941 had documented genuine engineering achievements. The Jeep represented sophisticated solutions to complex manufacturing problems, eliminating unnecessary complexity while maintaining operational effectiveness. But those engineering achievements only mattered because they enabled mass production at unprecedented scales. A brilliantly designed vehicle that couldn't be manufactured in meaningful quantities possessed no strategic value. The Americans had understood this fundamental principle and built their entire military vehicle program around maximizing production efficiency. The influence of that philosophy extended far beyond immediate military applications to fundamental questions about industrial warfare that would shape post-war strategic thinking. Nakamura spent considerable time during the occupation years analyzing how American industrial practices had contributed to Japan's defeat, writing technical assessments that would influence Japanese automotive development for decades. His most significant conclusion challenged assumptions that had dominated Japanese military thinking throughout the war years. Superior individual equipment quality cannot overcome massive quantitative inferiority, he wrote in a report circulated among post-war industrial planners. The Americans didn't defeat Japan through better engineering. They defeated Japan through better manufacturing. Their vehicles weren't necessarily superior to ours mechanically, but they possessed such overwhelming numerical advantage that individual quality became strategically irrelevant. The Jeep production numbers provided stark mathematical proof of this principle. At the war's peak, in 1944, American factories manufactured more than 15,000 Jeeps monthly, while Japanese automotive production had declined to fewer than 2,000 vehicles monthly across all military categories combined. This 7-to-1 production advantage translated directly into tactical mobility, logistical flexibility, and operational capability that Japanese forces could never match, regardless of individual soldier quality or tactical skill. The post-war analysis revealed additional dimensions of American industrial achievement that hadn't been fully appreciated during combat operations. The distributed manufacturing network that produced Jeep components had involved over 1,500 different suppliers across the United States, Companies that formerly manufactured refrigerators produced electrical components. Furniture makers supplied wooden components. Small machine shops across the country manufactured specialized parts to standardized specifications that allowed assembly at final production facilities. This industrial mobilization hadn't required building new factories from scratch. Instead, Americans converted existing civilian manufacturing capacity toward military purposes with remarkable efficiency. The same production lines that assembled civilian automobiles in 1941 were manufacturing military vehicles by mid-1942. The workforce that built consumer goods adapted to military specifications within months. The industrial ecosystem that supported peacetime consumption redirected toward wartime production with minimal disruption. Japanese industry possessed no equivalent capacity for such rapid conversion. The handful of companies manufacturing vehicles operated at maximum capacity throughout the war, unable to significantly increase output despite desperate military requirements. The absence of extensive supplier networks meant that each manufacturer had to produce most components internally, creating bottlenecks that limited maximum production regardless of available labor or raw materials. The concentrated industrial structure that had seemed efficient during peacetime proved inflexible when wartime demands required rapid scaling. Nakamura's final assessment, completed in 1947 while working as technical consultant for Toyota's post-war reconstruction efforts, synthesized lessons learned from analyzing American Jeep production across the entire war. The Americans taught us that modern industrial warfare isn't won by the side with the best equipment, but by the side with the most equipment that's good enough. The Jeep wasn't the finest military vehicle ever designed. It was the finest military vehicle that could be manufactured at the scale modern warfare required. He reflected on the captured Jeep he'd first examined at Clark Field in December 1941. That simple machine his team had initially dismissed as crude American manufacturing shortcuts. We spent years perfecting complex vehicles that performed brilliantly in limited numbers. The Americans built simple vehicles that performed adequately in unlimited numbers. They understood that adequacy multiplied by 600,000 exceeds excellence multiplied by 6,000. That lesson cost Japan a war to learn. The legacy of American Jeep production extended far beyond immediate military applications to reshape global understanding of industrial mobilization and strategic planning. The 639,000 vehicles manufactured between 1941 and 1945 represented the largest production run of any military vehicle in history up to that point. But more significantly, they demonstrated that democratic societies with market economies could mobilize industrial capacity for military purposes at scales that exceeded totalitarian planning systems. Japanese military planners had assumed that America's individualistic culture and distributed economic decision-making would prevent efficient wartime mobilization. Instead, the Americans demonstrated that industrial economies built around consumer manufacturing could convert to military production more rapidly and efficiently than command economies designed for centralized control. The Jeep program proved that commercial automotive companies could manufacture military equipment at scales government arsenals could never match. The vehicles themselves served in every theater of World War II, across every continent except Antarctica. They hauled supplies through North African deserts, towed artillery across European battlefields, navigated jungle paths in Southeast Asia, and transported commanders across Pacific islands. They served as ambulances, communications platforms, weapons carriers, reconnaissance vehicles, and countless improvised purposes that designers had never anticipated. Their simplicity made them adaptable. Their reliability made them trusted. Their abundance made them indispensable. Photographs from the war's final days show Jeeps everywhere in American military operations, leading columns advancing through German cities, carrying commanders at Japanese surrender ceremonies, transporting occupation forces into former enemy territories. The vehicles that Japanese engineers had first examined with skeptical amusement in December 1941 had become the ubiquitous symbol of American military might, present at every significant moment of the war's conclusion. In the decades following the war, many of those 639,000 Jeeps found civilian second lives. Farmers purchased surplus vehicles for agricultural work. Delivery companies converted them for commercial service. Recreational users discovered their off-road capabilities. The simple, robust design that had enabled mass wartime production proved equally valuable in peacetime applications. Jeeps, manufactured in 1942, were still operating in 1972, testament to engineering that prioritized durability alongside manufacturability. But perhaps the most significant legacy involved how American Jeep production influenced post-war Japanese industrial development. Companies like Toyota, which had struggled throughout the war to manufacture small numbers of military vehicles, studied American mass production techniques with the determination of students learning from masters. They recognized that Japan's post-war recovery required adopting manufacturing philosophies that had enabled American industrial dominance. The principles of standardization, supplier networks, quality control, and production efficiency that Americans had demonstrated through Jeep manufacturing became foundations of Japan's post-war automotive industry. By the 1970s, Japanese companies were producing vehicles with quality and efficiency that challenged American manufacturers on their home territory. The defeated students had learned their lessons well, eventually surpassing their teachers in many aspects of automotive manufacturing. Colonel Nakamura, retired and working as industrial consultant, watched this transformation with satisfaction, tinged by bitter memories. The Jeep that had revealed American industrial superiority in 1941 became the template for Japanese industrial recovery in subsequent decades. The production techniques that had enabled 639,000 wartime vehicles eventually produced millions of peacetime automobiles carrying Japanese brands worldwide. We learned that warfare is ultimately about industrial capacity, Nakamura reflected in a 1975 interview. The Americans understood this instinctively. They built not just vehicles, but manufacturing systems that could produce vehicles in whatever quantities the war required. That was the real American secret weapon. Not any particular piece of equipment, but the industrial ecosystem that could manufacture equipment faster than any enemy could destroy it. The final Jeep of World War II rolled off the production line at Willys-Overland's Toledo factory on August 20th, 1945, just 5 days after Japan announced surrender. That vehicle, number 639,537, represented the culmination of an industrial achievement unprecedented in military history. From initial design in 1940 to final production in 1945, Americans had created, refined, and manufactured a vehicle that helped win the largest war in human history. Japanese officers who had first examined captured Jeeps with skeptical laughter in December 1941 learned a lesson that military historians would study for generations. Superior engineering excellence means nothing without industrial capacity to produce it in meaningful quantities. Adequate equipment manufactured in overwhelming numbers defeats excellent equipment produced in limited quantities. Industrial mobilization matters more than individual weapons quality. These principles, paid for with Japan's strategic defeat, became fundamental doctrines of modern military planning. The 639,537 Jeeps stood as mathematical proof of industrial warfare's ultimate equation. Not the best vehicle, but the best vehicle that could be manufactured at scale. Not the most sophisticated engineering, but the most manufacturable engineering. Not excellence in limited numbers, but adequacy in overwhelming abundance. The Americans had understood these principles and built their entire military vehicle program accordingly, and Japanese officers who couldn't believe Americans built 640,000 vehicles in 4 years learned that disbelief doesn't alter mathematical reality. It only delays recognition of truths that industrial capacity makes inevitable. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.